Good morning, my superhuman friends. Welcome to another Super Sunday live stream. I think I just used up all my energy for the day in the intro. But before I totally crash and burn and end the live stream, I need to do the acknowledgement. I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Now, I've got to do a very important shout out today. The important shout out is to Erica for bringing Dodgy his coffee so that there will be peace in the chat. So thank you, Erica. Chip, no coffee available here. What's going on? Mr. Hippo, yes, you're all superhuman. Oh, Rick Astley passed 1 billion views this week. That's the important news of the day, Johnny. Yes. Okay. Rick rolls for the win, yeah. So yeah, I've mentioned this before, the Rick Astley hotline run by my friend Paul, which is what he did was set up a VoIP system, and whenever you dial it, it just plays Rick Astley to you. And the idea is that what you can do is if you're signing up for some spam thing, like giving your marketing information, or you're on a date and you want to give a phone number, but you don't want to give your real phone number, you want to give them a fake number, you give them the number to the Rick Astley hotline. So I think Paul has single-handedly contributed to more rickrolling of people than anyone else in history. Yes. Okay, so now we've got the chat full of Rick Astley lyrics. Okay, so what to do today? Now, in my head, I thought there were three topics to cover today. And I can't remember topic number one. There was only going to be one little thing to pass along. I think I do remember it. I think what I was going to do, oh no, that was number 2. Anyway, what I was going to look at were the UT61e Wi-Fi project and the current status of that. And and also continuing the conversation about the universal rack controller, because now the PCBs have gone off for fabrication, and in fact we can check the status of fabrication. Let's do that. Desktop. Let's see. JLC PCB. Let's see where they're up to. And yeah, I think this is the first. I can't remember if this is the first live stream I've done. I think it is. The first live stream I've done. No, it can't be the first one. Since getting this ridiculous monitor. But how was I doing screen sharing last time? I don't... No, that's right. Last week, I still had the temporary setup with the old monitor and one on the side. Anyway, the point I'm getting at is, right now I am sitting in front of this ridiculous 49-inch whatever they call it, super ultra wide monitor. And so when I do screen sharing, what happens is that OBS grabs a small portion of the screen, not the whole screen. And that means that it's not obvious. Like, I can't just maximize a window and have it fill the screen that you see. I have to move a window around and watch what I'm doing in OBS so that I can see what you're seeing and how much of the screen you're getting. So what I'm going to do, I think, is I've got another, just a regular HD monitor. I'm going to get that and attach that as well and use that as the screen sharing thing for doing live streams. That will make everything a whole lot easier. What am I doing? Order history. Let's see where these universal rack controller PCBs are up to. Unfortunately, they take a little bit longer because 4-layer boards take a little bit longer on fabrication, and also these ones are making progress, and also because I picked non-standard colors. So with PCB, with small batch PCB places like JLC PCB, what they do is they batch up orders. So if you just order a standard 2-layer 1.6mm green PCB, they just batch your however many there are up with however many else they've got to go onto a panel. But if you order something unusual like a 4-layer with blue silkscreen, they have to wait until there are enough to fill a panel, and that so basically you're waiting for other people to order the same combination of parameters before they can put it into production. So there's often a small delay before the production even begins. And so production progress. So this one is the breakout for the LCD, and that one looks like it is, how far? It's profiling V-cut scoring, which is basically done. It means the boards exist, they've been tested, and what they're doing is just doing the cutting around the edge of the boards to separate them all, because they're still in their little panels or whatever they are. And then final inspection, just to make sure the machine didn't screw it up, and then they ship it off. So those ones are almost done. But these ones, the universal rack controller PCB, in fact I should show you that because it's been discussed a lot on the Superhouse Discord. But if you haven't been hanging around in Discord, you might have overlooked a whole lot of that discussion. So I'll show you this board in just a moment and how it's coming about. So what have we got here? Okay, so we've got to imaging outer layers, and it is currently in pattern plating. Okay, so it's pretty well progressed. Then it goes to optical inspection, solder mask, silkscreen, hassle, etc. So yeah, as you can see there, it's reasonably well progressed. It should be probably a couple more days, and that will be done and shipped. It is now Sunday, so if it ships, say Tuesday, give or take, and DHL does its thing, I may have those boards by the end of the week. We'll just have to wait and see. And there is also the stencil that you can just see at the bottom of the screen there. So I ordered a stencil to go with the universal rack controller, the ESP32 version. Now, some of you are probably thinking, what the hell is he talking about? What's this universal rack controller thing? And yes, I have talked about it quite a bit on previous live streams, but let's have a quick update on where the design ended up. Because live stream last Sunday, it was not final. It was a kind of concept. Sorry, I'm off the side here, out of your viewing area, but just finding the correct project hardware. And I'll show you this in 3D as well, because that's probably actually a good way to look at this. All right, so come on, back over here. Let's, where do we need this? I need that about to there and about to there. So there, yes, that's what you can see, approximately. Okay, so what have we got? First sheet in the schematic is pretty self-explanatory, nothing exciting in there. It's got an ESP32 just with a Vroom32 module, and after suggestions in Discord, this could be either a Vroom32 or a Vroom32e, and the E version is for external antenna. And because of course all of this is going inside an enclosure, which is most likely going to be aluminium, it's going to be inside a metal box and shielded. And for me personally, I actually don't care about Wi-Fi in this application, because I'm going to use Ethernet to communicate with the microcontroller. Like with this device, it's going to be sitting in a rack with Ethernet plugged into it. But many people may want Wi-Fi, and so what you can do is put a Vroom32e module on it, and instead of having the PCB antenna, it's got a like a micro FL, UFL connector on it, and then you can put a Wi-Fi antenna, like a, you know, one of those little rubber duck antennas through, say, the back panel of the rack enclosure, plug it in, and then you'll have fantastic Wi-Fi coverage because it'll have a good quality external Wi-Fi antenna hanging out the back of the case. And we'll get to that. In fact, let's, where's the, I'm still losing things on here. Okay, so this, if I can resize it, is how the board has ended up. And so you can see up here the Vroom 32 module, and it's got the PCB antenna. Now the Vroom 32e is a bit shorter. Instead of having this tab sticking out the end with the antenna, the PCB ends approximately where that horizontal line is for my cursor, and down in the corner here is the UFL connector. But luckily it is pin compatible, so what we can do is assemble these either with the just with a Vroom 32, or we're going to assemble them with a 32E and use an external antenna. And I've ordered a bunch of 32Es. They haven't arrived yet, but I've ordered them, so I'll be able to assemble them with either. And what you can see there is Austin. You may be late, but you're here at least. Thank you for coming along. Yeah, so Dodgy says, I like the idea of the extended antenna so it can be removed. Yeah, it's extra complication and expense because what we'll need to do is source Wi-Fi antennas. Well, we'll have to source a pigtail, so a connector, like a panel mount connector with a cable coming off the back of it with the UFL plug on it, and that'll have to be mounted through the case, and then we'll need an antenna that connects on the outside. So that's extra expense and messing around in assembly, but I think it's really good to have that option, and it makes no difference as far as the board is concerned. So the PCB is designed to take this module, and then all we have to do is replace it. We just populate it differently. So we can choose, do we want to go the simple route, which is the regular Vroom 32, in which case Wi-Fi performance is probably going to be pretty bad. My guess is it'll work. Wi-Fi will probably get through the case, but it won't work very well. So if you have, for example, a wireless access point somewhere near your rack, it'll probably work. But for a really good Wi-Fi performance, it means we can put a 32E on there, run the external antenna, and then life is good. So one thing that I have been debating is how much to share about the financials of this. And the reason I mention that right now is the issue of deciding on the antenna and how that impacts final cost and how this sort of thing is packaged and sold, like whether it's sold as a complete unit already assembled in the case, or whether it's sold as just this board for people to put into their own enclosures. Lots of options. Chip, you found a different form of caffeine, brain booting. What sort of form did you find? Was it no-dose pills? I've got my my genuine Troll Tech. You can't really see that. So my Troll Tech Troll Fuel form of caffeine here. So this is from LCA Melbourne 2008. I've still got this stubby holder that I still use for my caffeinated beverages. All right, so energy drink. Austin said ESP32S has both an onboard PCB trace and a UFL connector. That's interesting. Usually in those sorts of situations, there is something like a 0 ohm resistor that needs to be changed on the PCB, because you end up with, if you keep the PCB antenna connected, when you plug in the external antenna, the tuning just goes to crap. So you need to have, so usually in that sort of situation, you have to get in there with a soldering iron and do something like change a bridge so that the antenna is connected to either the traced antenna or the external antenna, which is a bit of a pain. So for many people, if they don't want to be messing around with changing, moving the position of surface mount components, that can be quite a barrier. Okay, so what was I talking about? Oh yes, all right, so financials. I might get back to that. This is something that I've held off for a very long time. And it's kind of got to the point where I've started thinking, I don't care about keeping it secret. I'm very tempted to like reveal everything, all my build costs and all the parts costs, like a fully costed bill of materials with assembly costs and everything, so that people understand what's involved in this. Because I could, in fact, I already have done all the calculations. I've got the spreadsheet. I've got the BQT spreadsheet, the batch quantity totals, and I could just say this board is going to be X dollars, and everybody's going to say, what? Why is it so expensive? All your stuff is so expensive. It's a rip-off. And maybe if I revealed how all the calculations are done, it might head some of that off. But it might make it worse. It might make people look at my spreadsheet and say, look, you could save money here. Or why are you... Yeah, anyway. Could be scary. Could be very scary. Yeah, so... back to this board. All right, so this is... This, for those of you who have just joined this this whole process quite recently, oh, Johnny. So put a pink LED on the ORC. I don't think I have proper stock of pink LEDs. What LEDs do we have? I think we've only got one. The only one we've got on here is the power LED. Or is there TX and RX? Oh, no, there are a bunch. I forgot. We've got the LEDs associated with Ethernet. So we've got activity, full duplex, link, and 10/100 indication. So we've got 4 LEDs there. There is a power LED somewhere. Where is it? Oh yeah, we've got TX and RX here on USB. And where it says LED there, that's actually a link for an external, that's a connector to an LED, like a panel mount bezel that will go in the front panel. And Sion says, sounds like this is referring to the financials, sounds like the biggest can of worms opening ever. Make sure you put your thick skin coat on before opening up the financials. Yeah, I've been really worried about doing it. So in terms of the financials, I was thinking of, I'm not going to reveal everything about how my businesses work, but reveal the costings of the parts that it costs to put a board together. Like what does it cost to actually make this board? And all right, so LED, so that's for the panel mount LED. And there is also a power LED somewhere on here, which is not, I didn't put a border around. Oh, there it is. There's the power LED up there. So anyway, as I was saying, I don't have proper stock of pink LEDs. I've got like a miscellaneous LED color pack, like a sample pack, but it's only got, I don't know, 5 each of a whole bunch of different colors. So I've got some really, really cool colors. There are some that just look amazing. Like the pink ones look good. I've also got purple. There are LEDs that are like a, how do I describe it? It's like a really intense green. It's, yeah, I don't know quite how to describe it. It's like a normal green LED is like it's like the traffic light green. It's like a bright green color. These other ones I've got are like a jade green. They're like a really deep, intense green, and they just look fantastic. So yeah, I have sample quantities of all sorts of colors, but What I do not have is production quantities. So if there's going to be something like a pink LED on here or a purple or jade green or something, I will need to buy some. Yeah, the jade green ones look surprisingly good. It's a really nice color. So the power LED on the front. My general idea is that what we would do is use something like a chrome bezel LED and mount it through the front panel, and then there'll be a flying lead that comes off the back of it, and it will plug into this connector. So that's just a connection to. Oh, what did I do? I put an what is this? That is a 4K7 resistor. Okay, so I actually shouldn't have put 3.3 volts on there because it is not 3.3 volts. It's being supplied by 3.3 volts, but it's got a current limiting resistor on it. And I think part of the idea here was that I was leaving my options open because I don't even know what LED is going to be connected to this. It's going to be some kind of a front panel bezel, one of those little chrome things most likely. And a lot of them have internal current limiting resistors. So when you buy them, you order them for the voltage that you want to run it on. And you might order them as like 12 volt or 5 volt or whatever. And if we end up using LEDs that don't have any internal current limiting resistors, then we can populate this resistor to suit. If we end up getting them with built-in current limiting resistors so that they are designed to run on 3.3 volts, then all I need to do is put a 0 ohm resistor in this spot. Just bridge it through, and that'll expose raw 3.3 volts on here, and then the LED will run with its internal resistor. So we've got flexibility. We can use it or not. We can make that decision when it comes time to actually assembling the cases. Jordan said no multicolor for the front status LED. Very sadly not. What I would love to find, and I've actually been in need of this for another project, is a panel mount, like a bezel style LED with like a WS2812 in it, because then you could just put it on a chain with other LEDs and drive it. All you need to do is give it ground power and data, and you can set it to whatever color you like. That would be super cool, because what I would love to be able to do with this is have the front panel LED indicate some kind of status. So this is something that my friend Andy does with his projects, is he puts a WS2812 on them, and then the color changes. And this is what we did also with the multimeter interface. So when it first boots, it might come up as, I can't remember what standard color sequence he uses. I need to find out and write it down so that I use the same sequence as well. But it's something like it starts off in red, which means that it's booted but it hasn't gotten anywhere yet. And then it changes color when it connects to Wi-Fi to show Wi-Fi is connected. Then it changes color again when it's connected to MQTT. And then it changes color again when it's like fully booted and ready to go. So then what you can see is the boot status. And you can see if, for example, it's hung up at not being able to connect to Wi-Fi, it'll stop at that color. And then you know where the problem is. So pretty handy. Of course, on this project, we've got the LCD as well, so we're going to get all of that boot information on the screen. Yes. Oh, so Dodgy says, like Xeon does with the tiny Pico when you first get it. Cool. What else? So front panel on the right, we've got the Ethernet connector, we've got the USB-C connector. Internally, we've got the I2C breakout, which goes to the other board, like the light switch board. We've got the SPI connection here for the LCD and power supply down the back. Now, this is one of the big decision things as well, and possibly slightly unknown. There is a PoE regulator on here. Now, there is a this is a regulator module that I've never used before, but my original plan here was that I was going to put on a Silvertel module, and I went looking for Silvertel modules, and because of the whole great chip shortage thing going on right now, they are currently unobtainium. So I looked around for some alternatives, and I found these really cheap little PoE regulator modules But the problem is that I've been able to find almost no information about them. I've ordered a bunch and they are currently on their way to me. But the only, in fact, I wonder if I have it here. Somewhere around, I've got, I'd have to go searching. I've got a piece of paper which I printed out a picture of the module, which has got a couple of dimensions on it, but most of the dimensions just aren't there. So what I had to do was, and it's got 0.1 inch pitch headers on it. So I know the pitch between the pins and the overall dimensions and almost nothing else. So when I was doing the dimensions for this particular module, I measured between 2 points on the piece of paper and then did the ratio of what that represented and figured out the scaling factor, and then measured other dimensions and applied the same scaling factor. So I've ended up with this really dodgy, in fact, let's, I'm doing a whole lot of hand waving when we could just be looking at the thing. So I did a really dodgy 3D model of it, and I'm not entirely sure whether it is physically going to fit properly into the space that I have. And I won't know until I, oh, come on. I don't want to have to log into this. I'm going to drag that off there. And this means I'm going to have to validate. All right, let's do, and the thing is I've got to get my password as well. So, just got to make sure that my my password is not visible on screen. I've got a thing that uses a hardware dongle to unlock my password vault. All right. I think all of that happened off screen. Oh, great. Now I've got to put in the 6-digit validation code, which I think that's it. And now we should be into Autodesk, maybe. 1, 2, 3, 4, 5, 6. Yeah, password 1. Hunter 2. Swordfish. No, what is it? IDKFA something. What was the Doom God mode? Oh no, close that. Bring this up here. Yeah, to keep it simple, I make my password is always just 6 asterisks. So you see this thing. This is the project. No, I do not want to use the recovery file. I think I had it open when oh, Peter, you're off already. Okay. Bye, Peter. Thanks for coming along. Yes. What was it? Some call it fun said IDDQD. Was that the Doom cheat code? I can't remember. It's so long. Now, what are you doing? Must be lunchtime soon. Yeah, if Peter has left, it's lunchtime. Stream buffers every time Fusion loads projects. Well, that sucks. Yeah, I can see in OBS that the yeah, maybe this has got something to do. Remember last time? Remember last time? I wonder if there is some bad interaction between Fusion 360 and OBS. I'm just going to kill this off. No, no, no. Come on. And has it gone? Is it going? Okay. Is the stream back? Is the stream back? I don't know. I think it is back. All right, now, so remember last week, this same thing happened. I tried to open Fusion 360 while I was on the stream, and it hung, and I force killed it. I did it several times, and it never actually opened. And then after I finished the stream, I opened Fusion 360 and it launched and worked perfectly. I have a feeling that there is a problem there's an interaction problem between Fusion 360 and OBS, which is a very weird thing. I don't understand what's going on there. Dedicated streaming machine. Yeah. And all week I've been using Fusion 360 and it has been absolutely flawless. So I don't know why I can't launch Fusion 360. Yeah, there's something like that. I can't use Fusion 360 when I'm on a live stream. Now, what would be very interesting would be if I had Fusion 360 open and then began a live stream. But unfortunately, it looks like no visuals not updating, Sion says. Hopefully it will be. Okay, back now. Cool. Yeah, okay, so if I had it open already and then I launched OBS, I wonder if that would work. But F360 has an anti-streaming function in it. Dodgy says. For some reason that would not entirely surprise me. Okay. Jax Tech says, both trying to exclusively control the GPU. Anyway, okay, so we're gonna not have 3D views of this, but we can look at some renders. If we go to GitHub, not LSC, I want to go to URC, and you can see there is a render of the board. So this is what we've just been looking at in Eagle. So this board is this one right here. Now, there are a couple of things that I did. So yeah, LEDs we were just looking at are up here. And this is the connector for the front panel LED. I've got jumpers here on the I2C pull-ups. And what I was talking about over here was the PoE regulator. So this module, you can see there's a 3D model of it in there, but this is my kind of very rough guesstimate, best effort at the physical shape of it. And I've made it so that it just clears this capacitor. Like from the angle that we're looking at this, it looks like it's actually going through the capacitor. But this, so this is the inductor on the PoE regulator module. But what I'm not quite sure of is how far offset this is from its pins. So this is all, so this whole back corner of the board is a bit of conjecture. Super delayed chat. Oh, okay. Hopefully it's going to kind of fix itself. I don't want to have to end the live stream and then start again, because that would just be annoying having it segmented like that. So let's continue and hope that YouTube catches up or OBS figures it out or something. So I've got another view. I'm watching the video. I can see the broadcast studio thing in YouTube, and I'm trying to figure out how far delayed it is from the time that I do stuff to the time that it appears in YouTube. And it looks like there is, yeah, there is quite a long delay. There is a really long delay. Oh well. Okay. I'll just get on with it and hope that everything is okay. So this area, the PoE regulator, because these PoE regulator modules are really cheap, I can't remember the number, but I think it's like they're in the order of $4 US. Like they're really cheap. It means that it's possible to put this on so people putting time in there to see what the delay is. Yep. So it is possible that what we could do is populate this on all of them, because my original idea with the Silvertel module is that because Silvertel modules are fairly expensive, it was only it's dodgy. In Queensland, we're 16 years behind. A few more seconds won't hurt. So I was thinking that of just making it an optional extra. But if we can have full PoE support on this for only US $4, which by the time you've got assembly and all of the other overheads in place, it actually works out to be way more than $4. But still, if we can put, I'll put a clock app on the screen. Okay, where do I get a clock? Where do I get a clock? I don't know. Is there I don't think I've got a clock. I'd have to install a clock app on my computer. All right, anyway. So then if I'd like to be able to ship this with PoE support out of the box. And it may be that we need to do a cut down version because some people won't care about like 48 volt PoE. They will only care about DIY PoE or won't care about PoE at all. And this is the big untested thing. So what I've got here, in fact, if I open this up a bit bigger, we'll see it a bit better. What we've got here is the module, and these two jumpers basically bypass the module. They link the input side to the output side and essentially short circuit directly across it. Google, what time is it? Okay. What time is it? 10:37 a.m. in Ringwood East, Victoria, it says, which is not actually my suburb, but it's pretty close. I'm in the east of Melbourne, and it's certainly in the same time zone, but it doesn't have it in seconds. So 10:37 when I did that. Okay, so in the schematic, now there are a couple of things that are a little bit dodgy about this. One thing that I often end up overlooking is the current carrying capacity of things like pin headers and small switches. And a lot of the time they are really surprisingly low. Like pin headers with jumpers aren't too bad. You can get a bit of current through that. But what this is doing is taking the input side. So we've got, on the input side, we've got PoE EV plus coming from the, so this particular mag jack has bridge rectifiers built into it. So what we get coming out of here is positive from PoE and negative from PoE going into the module. The module itself actually has its own onboard bridge rectifiers, so it's just, yeah, it's not really necessary to do it, but the Ethernet sockets that I prefer to use already have it built in, so it's kind of going to get rectified twice. It's going to be a little bit of voltage drop on those diodes, but oh well. So what we have then is the possibility of bypassing the negative side and linking it straight to ground, and the positive side linking it straight to the output side on the positive and bringing it into the input of the voltage regulator. So what we've got here is, if these jumpers are in place, it will bypass this PoE regulator entirely and pass the raw PoE voltage straight through to the board. Yeah, Sion says small switches are terrible, usually 300 milliamps or less. Exactly. Yeah, there are a lot of Chip says silly lunchtime here. I don't think I'm quite that far behind or ahead. So small switches, it can be really quite surprising. Some of them are very, very low. Like if you look at the specs on a lot of little slide switches and things like you would typically put on a PCB, some of them are shockingly low, like 50 milliamps. Many of them are 150 milliamps. And so some of the things that you see as power switches on projects, like a power switch on an ESP32 project, for example, if you have a switch in series with say a battery or just the voltage regulator going to this, or the battery to the voltage regulator going to this, that switch is going to need to be able to pass 600 milliamps or more. And it's amazing how many projects you see that have a power switch on them, and the power switch might be rated to 100 milliamps, and it's in the main power rail to the CPU. So what was I talking about? That's right, yeah, so pin headers. Pin headers can normally, and jumpers, the little jumpers that go over them, they're actually normally pretty good. You can get decent current through those, surprisingly, because the pins themselves are big chunky bits of metal, and the jumpers that go across them are usually fairly wide, like they've got big contact areas. So the current you can put through pin headers and jumpers is way more than you can put through typical small PCB mount switches. So this is the theory. It is possible that the first time I power one of these up with these jumpers in place, this PoE regulator is going to say, nope, I don't like this one little bit, and let out its magic smoke. I don't think it will, but it's possible. We can live in hope. What else is there to say? Not really much else to say at this point. But this is the end. Oh, okay. No, there are a couple of last minute changes that came about because of discussion on Discord. So starting from I'll just talk about I/O for a moment. This is the non-surprising thing, the I2C breakout. So that's just got ground, and it's got the 12 volts coming in here, which is the power supply to whatever other boards are attached. And where are we? Over here, 3.3 volts. So it's providing logic voltage and like 12 volts for running your light switches and other things. Then it's got SCL and SDA and reset and ground. All very straightforward. This header here, I might get back to this because I'm going to talk about the module, the LCD module. Dodgy has asked a couple of times, onboard watchdog. No, there is not one on this board. I thought about it early on, and then it kind of went out of my mind and I didn't think about it. And then after I'd sent the boards off for fabrication, it was brought up again, and I thought about, is there a way to retrofit one? If reset was exposed on this header, you could retrofit one pretty easily, but it's not. So you could, switching part. Is that about the PoE regulator? I'm not sure. Yeah, I will get to that. All right. In fact, let's detour. I will get back to the I/O, and I will detour back to this. So this switching regulator, yes, let's look at what it is. It is a DP1435, and it is, in fact, I'm just thinking, being totally mercenary, I'm going to drop, let's see, I'm just going to take this off screen because I'm going to open my my Google Docs folder and find the link to the part. So if anybody wants to experiment with this particular part, they can. And that one. No, that looked like the wrong thing. Oh no, it is the right thing. Okay, so Please excuse me for a second while I get this sorted out slightly off screen. All right, now I'm going to be totally mercenary here and drop an affiliate link into the chat. And what it is an affiliate link for is this. There, about there. Okay. Yeah, so US $4.07 plus 19 cents shipping, although that's on Caneo Super Economy Global, which is super slow shipping. So if you change it to, and there are many sellers of these, like if you change it to e-packet, it's $2.43. So $2.43 plus $4.07 is $6.50. So US $6.50 converted to Australian comes to like $9 Australian. Anyway, so PoE regulator module for somewhere in the region of $9 Australian, which is pretty good value. And it's got on board, yeah, so what I've got to work from is somewhere down here. There is a, okay, this diagram right here. This is what we've got. So we know the pitch. It's obviously just 0.1 inch pin headers, but there are so many dimensions on here that are just missing. So there's, yeah, we can see that distance there, but that's the length of the pins. That's no use to anybody who cares about that. There is the distance from the back point there to the front point is 16.2 millimeters, but we don't know what the offset is. Like the front of the PCB here, what is the distance from the front of the PCB to this point here? So how high is this inductor? We don't know because there are just too many missing dimensions on this. It actually only needs a couple more dimensions added and this diagram would be so much more useful, because you could start deriving, like you can infer, once you've got a couple of reference points, you can start inferring other dimensions. But there are too many dimensions that aren't related to anything else. Like the total thickness, the distance from that side of the inductor to the back part here. Okay, we know it's 16.2, but where does it start and where does it end? Where's the reference point? Where's the offset? So many things like that. Anyway, so this is what I was working from in order to make my model to try to make it fit. And so I don't know how far this inductor protrudes from the front of the PCB. And I don't know, I mean, I can figure it out on the basis of what's normal for pin headers, but I don't know the distance between the center point here of the pin and the PCB. So all of these things that you need for calculating clearances, they're just not there. But it seems like a very interesting little module. You can see on the back that it's got two bridge rectifiers here. So it does have onboard rectifiers, and what I'm doing is just feeding into one of them and ignoring the other. And yeah, anyway, hopefully that ends up being a useful and decent little thing. So good question, Dodgy. So Dodgy said, would the PoE have enough juice to supply ESP32, LSC and RSC? Now, this comes down to questions of power, and this was discussed on Discord as well, because there are applications where you want lots of power, like the power distribution unit, which is one of the potential modules for this. And Sion suggested messaging the seller. Maybe I should have done that, but I just ordered them. Yeah, so the what was I thinking of? Oh yeah, power. So Dodgy's question about power. Now the big limiting factor here is the PoE standard, and it's around, from memory, it's about 15 watts. Let's see if it's got it in the specs anywhere here. Let's see. PoE class 0, I think, is the magic term that we want. So there are different power classes. Power sourcing equipment. Okay, so what we want is, yeah, here we go. Power available at PD, so power device. Right here, 802.3 AF, type 1, that number there, 12.95 watts. That's the most that we can expect to get out of this. And that is, so if that's at 12 volts, that means you've got basically an amp-ish with some losses and things involved. So there's really not a huge amount of power. What we're doing is regulating some down to run the ESP32. So the way I, yeah, okay, so Dodgy says, can't see it using anywhere near that. But if you're doing, for certain applications, you absolutely would use that and way more. If you're doing smart light switches, and the light switches have an ESP8266 in them, and you turn them all on at once, and they all boot up, and they all start doing their Wi-Fi tuning thing, they could be pulling a few hundred milliamps each. And if you've got 20 of them, you've got a significant amount of power that you're going to be pulling in a very short period of time. So this is mostly for doing things like this is perfectly adequate for running the simple light switches, which has just got illuminated buttons on them, and things like the light switch breakout board, plus the onboard controller. So this is really our limiting factor with PoE, whatever. Now, one thing you could do is you could pump more power down this by going for DIY PoE. And if we switch back to here, so if you bypass this onboard regulator and you you do a PoE injector at the other end, you could shove more than an amp at 12 volts. So what you do is just feed 12 volts into it. Instead of using a proper 802.3 AF power over Ethernet switch, what you would do is use a passive PoE injector and feed 12 volts into the Ethernet, and then bypass the regulator here, and then you've got more current available. Like you could have a 12 volt 2 amp or 12 volt 3 amp power supply injector at the other end. You'll get more losses in the cable because you're running at a lower voltage. But anyway, if you're running on the limit, that's something to consider. So I really wish that I can do this I can show you the mock-ups in Keynote. So there were things we did last week. I showed you some Keynote mock-ups. I'm going to get back to the I/O in just a minute, but for now, because one of the things that we really need to do now is do the case design. What am I looking at? Sorry, I'm typing through things off screen here. URC and URC rack layout. Okay, so let's have a look at the arrangement. So talking about power. Now these are some front panel mock-ups that we've looked at previously. And where were we? Maybe this one? Yeah, this one. This is a reasonable starting point. So my plan is to put 2 power connectors in the back of the enclosure. Have a 2.1mm DC jack, just the standard thing. So if you want to plug in a regular plug pack, you can do that. And also put an XT60 panel mount connector in there. XT60 is really commonly used in remote control planes and drones and that sort of thing. And it's rated to 60 amps continuous. And that should be plenty. If you're sucking more than 60 amps into one of these devices, I think you're going to have yourself some cooling problems, maybe. I'd be a little bit worried. The XT60 could be used for some kind of a higher current power source. And yeah, that way you can get around the limitations of the power over Ethernet. 12.95 watt limit on 802.3 AF. So back to what? Back to here. All right. So changes. Oh yeah, and there's a micro SD card on there, and I still don't actually have an answer on this. Why do people want a micro SD card on here? Like I can think of a couple of use cases, but what I would really like to know is specifics. To me, it seems like this is a little bit of a solution looking for a problem, and I've had a few people say it'd be nice to have a micro SD card on it, but in the applications that I can think of for this, I can't actually think of a reason to put a micro SD card in here. Yeah, Dodgy says cooling rear case fans. Maybe that was UPE Tech said XT60 is 30 amp continuous and 60 amp peak. Oh, okay. I thought it was 60 amp continuous, 90 amp peak, but maybe that is the peak, not the continuous rating. But in either case, even 30 amps, that's a lot to be pulling into one of these cases. So yeah, potentially we can get into cooling fans on the back. My objective is always to make these things passively cooled because I want them to be totally silent. But yes, we could have optional cooling fans in the back for people that want to do that. Because the whole idea is that this project, building the universal rack controller, the idea is to allow people to build whatever they like in this. This is providing the common infrastructure, so the physical enclosure, the Ethernet connection, USB, and a display, but that's all. And then whatever goes in the middle here is whatever your imagination allows. So if someone wanted to get it like this version of it with just the pass-through connectors, power connectors on the back with some flying leads, and the display, then they can build whatever they like in here. And maybe maybe you do want to build something that requires cooling fans and you don't care about keeping it silent. So there's yeah, when it comes to the design, we could put cutouts for fans in the back, and then if you want to put little fans in there, you can go for it. All right, so oh yeah, and this is my first intended application for it, just making the light switch controller. But that's only one possible application. Where was I? Yeah, so micro SD card. Has anybody put any ideas? I haven't been looking at the chat for a little while. Large website resources, Andrew said. Yeah, potentially. So if there's a web user interface for this, the micro SD card could contain assets like images and stuff. That is certainly a valid use for it. Okay. Jordan says graphics for the screen. Yeah. Stephen pointed out you have about 16 megabytes of storage if you go for the big ESP32 module. Yeah, but so you can do a SPIFS file system like the SPI flash file system with ESP32 and store assets internally, but perhaps assets on an external card could be useful. Other things could be data logging, perhaps. I don't know, but a lot of this comes down to the sorts of things that people will use this for. The thing is that in my head, I've been thinking of this as I'm building a light switch controller, but that is that is only one of many, many possible uses for this. And yeah, maybe the micro SD card is useful. I'm not objecting to it. I think it is cool putting a micro SD slot on here. I'm just curious to know what people are going to use it for. I want to hear other people's ideas, get some inspiration. It's when other people come up with stuff that it's really interesting. My own ideas are boring. Okay, so we've got the header over here which goes to the LCD. which I will bring up separately in just a moment, so we'll ignore that for now. Now, one of the very last minute changes, I'm just going to get rid of the bottom layer silkscreen to make it a little bit clearer. In fact, I'm going to get rid of, let's get rid of some more layers to make it even clearer what we're looking at. And one of the questions that Ben asked right at the last moment, just before this was ready to go off for fabrication, was, can we have some spare I/O? And so here we have spare I/O. And it's just, this was added last minute, but I think it's a really worthwhile addition. So what we've got is power and ground. Power just being logic power, 3.3 volts, and ground, obviously. Then we've got SDA and SCL. So this is the primary GPIO 21, GPIO 22. It's the primary I2C interface. So that is actually the same. Those connections are the same as exposed down here on the I2C breakout. They're just exposed here again in case you want to use them. Then it's got IO33 and IO32 as SDA2 and SCL2. So you've got a second I2C bus here that you can address entirely independently of the first bus. So if you want to connect into this header, you can then link that off to some other device. And in the case, I think it's Dodgy is wanting to have a connection. He wants to combine both the light switch controller and the output controller into the same box. So you could have this header going to one of them, and then up here you can have a second I2C connection and address the other one totally independently. And then there is also TX2 and RX2. So the second hardware UART, the serial port, is exposed on this header. And the big advantage of this is that it means you can do things like connect, you could connect to like a KNX type network, which I know nothing about, approximately zero. But there are people, including Ben, who are using KNX. And so having a serial interface that you can drive, so you could plug a little device into this and interface it with a KNX network, that can be useful as well. So it's got the two headers on here, which are for prescribed uses. They're for specific uses. And then there's the general purpose header up here, which you can use for whatever you feel like. Okay, so the other board, if we let's look at the TFT breakout, which is this one. Now, it would be nice if I could show you the 3D model of this. I need to figure out what's going on with Fusion and OBS. So this is a breakout for the LCD module. And originally I didn't want to have a breakout. I just wanted to mount the LCD module. In fact, do I have one handy? No, I'd have to go and grab one. No, I've actually had a couple of people ask about this. So I think it's worth, I'm just gonna switch here. I think it's worth actually showing this to explain the reasoning behind all of this. What am I looking for? SPI displays. I might as well explain it now. Now, this is actually the module that I wanted to fit in the enclosure, but it does not fit. It's a touch screen. Yeah, it's a. And here's a one of my jury-rigged test things with it. So it's a huge screen. We could possibly just make it physically fit in the rack enclosure, but it's really, really pushing your luck. So I gave up on that idea and went for these other ones. And also those ones are moderately expensive. Let's open this one up and I'll show you the problem and why we need a breakout. Now, is overhead going to work? Overhead camera, yes. But I'm going to give you the wobbles for a moment as I zoom this in. Can it focus? I'm going to take it in as far as it can focus. Hey, hooray, it focuses all the way in there. Very nice. All right, so this is the module, the screen that I want to use. This particular one has the screen already attached to a carrier with a driver chip on it. But there is a very important flaw with this particular thing. Now the header across the top here, which way does it go? I've got to turn it so I can read it. Yep, so it's got ground, VCC, serial, it says SCL and SDA, but it's not actually, SCL is serial clock, SDA is serial data. That is not I2C. Then there's a reset pin, then there is DC, which is data or command mode, and BLK, which is backlight control. So this is an SPI interface on here with a couple of other control pins. But when you stop and think about this, this is SPI. What pin does SPI need that is not on here? And that is chip select. So there's no chip select on here at all. And there really should be. So what that means is that if you connect this onto an SPI bus with other devices, this is always going to be enabled and you can't talk to any other device, including the Ethernet controller. So that really sucks. Now we need some way to isolate this display when we're talking with the Ethernet controller. The control chip that drives this display does actually have chip select, but there was a really dodgy design decision. Whoever designed this module in the first place, what they did was so one of these little strips on this, one of these connections on the ribbon cable is chip select. And what they've done is on the PCB, the chip select pin is hardwired to ground, which means that it is always enabled. And you can't deselect this device on the SPI bus. And the only way to isolate the chip select pin is to unsolder this ribbon cable, like this little flex cable here, lift the flex cable, cut a track on the PCB that is underneath the flex cable, and then put the flex cable back down and solder it all back on again. Now that is a total pain. You can do it, and there are people that, like, there are blog posts online, people showing that they've done this, but it's just, yeah, it's really annoying. So I don't want to have to do that for every one of these displays. Like, these little displays cost about $3 each, and I don't want to be spending 5 or 10 minutes reworking every one of them and potentially damaging, and yeah, it's just not worth it. So, and even then, even if I did that, what would we have? We'd have the chip select line just exposed on one of these little bits of pad, and then we would still have to connect it somehow. So what we would need is all of these connections plus another connection, which means we couldn't just put a header on here and then have a cable going to it and mount the display. We'd need to dodgy across a connection to the chip select line. All right, so that states the problem. This is the problem. We want to use this display because they're cheap, they're bright, they're good resolution. It's a 240 by 240 resolution, so they look pretty cool, but we've got no chip select. So how do you solve that problem? And what I've done is something that I actually don't know if it's going to work. It might be this might be a total failure. It's one of those things where it might be genius and it might be stupid, and I just don't know yet. So what I've got is this circuit. Now, starting from the right, which is kind of counterintuitive, but you'll understand why in a moment. This is the module. This is the 7-way, is it 7? I think so. 1, 2, 3, 4, 5, 6, 7. So this is the 7-way header that goes to the display module, and you can see it's got power and ground and backlight control, data command reset, and it's got serial data and serial clock, but it has no chip select. So over the other side, I'm going to ignore the middle for now because that's where the little dodgy hack comes in. We've got the SPI header, and what we've got here is mostly the same connections, but we've got 8 pins instead of 7. We've got ground, serial clock, TFT reset, TFT backlight control, TFT chip select, data command, we've got controller out peripheral in, and VCC. But this is the trick. So most of these things just connect direct through, like TFT reset, for example, just goes straight across. You can see that most of these connections are bridged directly from the IDC header through to the OLED. The exception is here. The serial data line does not pass through. We've got this buffer in the middle. So serial data comes in here, and it hits this buffer, and then it comes out of the buffer and goes into the OLED. So if this chunk in the middle wasn't here, this would basically be a direct pass through. We've got an IDC header on the left, passing through to the display module on the right. And then what I've done is taken the chip select line. Did I get this right? Whew, I did. In fact, I should have drawn that trace through. So what we've got is the chip select line and the output enable pin on here. So we've got a pull up on output enable, which means that normally this buffer will isolate the OLED and you won't be able to talk to it. But if you pull chip select low, it will turn on this buffer, and then data will pass through the buffer from the controller to the LCD. So this is my dodgy little hack that hopefully will make these cheap $3 LCDs behave the way they should, and be nice. Play on the same bus as other SPI devices. Yeah, yes. What was the question? Okay. Right, so we're just going to have to wait and see. If we go back to, where were we? Here, no, not there, not there, here. So this board here, which is in production at the moment, oh, I'm just going to get that out of the way. So this board is the breakout, and this is what will sit directly on the back of the LCD module. In fact, if we come back in here and go to this view, so what happens is that this sits directly on the back of the LCD. It connects into the headers in here, and it provides the IDC header just on there, and there's the buffer chip. So what this will allow us to do, if we go back to the Keynote version right here, is, where's the simple bit? Where's the simple view? That one? That one? Oh, that'll do. Anyway, so what it allows us to do is have the LCD mounted down here in the front panel and have an IDC cable plugged into that. That will then go to a Raspberry Pi hat, or it can go to the universal rack controller, or it could go to an Arduino shield. It doesn't really matter. What that means is that whatever we use inside the rack can communicate with the LCD as a regular SPI device, and it can disable it when it wants to and enable it when it wants to. Yes. So Johnny asked, sure it wouldn't misbehave as it still receives the clock. That is a very good question, and that is why I don't know if this is going to work. What I'm not sure about is whether, what I probably should have done was use the second buffer on that to pass the clock, to enable or disable the clock. But what I didn't know is whether disabling the clock would also kill the controller. And if I was being totally ass covering, what I would have done is taken the clock, wherever, yep, the serial clock, pass that into the second channel on this buffer and have it have the enable linked to the first one so that they both got enabled and disabled at the same time, and then take the output of this one into the clock on the display. And that way the clock would be disabled at the same time as the data line was disabled. And then what I could have done is put solder jumpers and stuff on it so that if necessary I could have bypassed the buffer to keep the clock connected. But I didn't do that. So we're going to find out. Probably at the end of the week, give or take, I'm going to find out if this works. How much per... Dodgy says, chase so many squirrels, almost forgot the original topic of how much per unit. Yeah, I had forgotten. Yes, so yeah, there is so what I've done on this particular thing, this buffer chip, the 74HC2G125, I chose this specific buffer because I'm already using it on another project. There is also a single channel version of this which is cheaper and smaller. It comes in like a SOT23 package, and so the squirrel needs a name. My vote is Steve the squirrel. Steve is an acronym for stream that end very eventually. Oh, yeah, I think the squirrel has a name. Steve the squirrel. Thanks, Aaron. Yeah, so if all of this works out as a cost-saving measure, ultimately, if we end up producing a few of these, what I would do is replace this buffer with the single-channel version, and that it actually is significantly cheaper. Like, I can get the single-channel version of this buffer for, I think it's about 19 cents US, and the two-channel version is more like 90 cents US. So you're actually better off using two of the single channel buffers. It just uses a little bit more space on the PCB. But this is what I have. So what I've done is try to design this around parts that I physically have in my possession right now, and I don't have to rely on shipping or anything else. So I have a big piece of cut tape with a whole bunch of these in it because I've been using them on another project. Speaking of which, parts availability, there is a hard limit right now. There is a hard limit on the number of units that I can produce. Let's have a look at W5500 on DigiKey. Check this out. Doesn't matter which one I pick, they're both the same thing. One's a full real price, the other one's not. Request stock notification. And if we go to LCSC and and go for W5500, and oh look, there is one there, availability 0. So yes, WISNet W5500s. If anyone has a source for these, please let me know. What about element 14? Element 14. But if they're out of stock at DigiKey and LCSC, then probably out of stock here. Yeah, I don't know. No individual chips, just these development boards with them already on it, which is no good. So I have All right, right now I have 16 W5500s. They are sitting up here on the shelf. My along with a couple of dev boards. So this is my entire stockpile of W5500s right now. Woo! And there are 16 on this bit of tape. So what which means I can use one to build for myself, and then I can build 15 more. And that's it, I'm out. I do have some dev boards here, so I can scavenge a few more off those and flow them off. But this is actually a serious problem now. Like, getting parts is a real hassle. So if anyone has a lead on a supplier that has W5500s in stock, please let me know, because that could end up being the limiting factor in assembling these. Yeah, so as Aaron said, Aaron just pointed out, I'll share the URC compatible logo I created for those that want to include it on their projects to make it easily identifiable to potential customers. Okay, so let's talk about the slightly bigger picture for a moment. I haven't talked about the multimeter thing at all. Maybe I'll get to that. We'll see. This might end up just being talking about the universal rack controller. All right, now, universal rack controller. We do need to get onto the enclosure design. That's I have deliberately ignored enclosure design discussion while I was working on the oh, try Octopart. Okay, Octopart. Yeah, I've deliberately ignored enclosure discussion while I was working on the PCBs because I just didn't want to get myself, you know, totally off track and industrial control, integrated circuits. Let's try that. What? I've applied the integrated circuits filter and it's still come up with things like DF robot shields. Okay. Stock. Arrow Electronics say they have 172. What else? What? Jack say they've got 100,000. That number seems fake. I think that's fake. But I'm just going to go to this and see what happens. So Arrow has them, yeah, 172. So I should order some, just to make sure that I can get some. In stock, 100,000. Why is that number so even? If I order one, is it going to go to 99,999? I don't think so. I don't think that number is going to change. I think they are lying to us. But if they actually did have 100,000, that would be nice. Yeah, so anyway, thanks for the suggestion of checking on Octopart. That's a good idea. So I'm going to, I would rather more trust Arrow Electronics to have an accurate stock number on here. Yeah. So if they say they've got 172, then they probably do have 172. And why so cheap? That is ridiculously cheap. I'm going to leave this open because I think I'm going to order. Oh, Arrow says MOQ of 250. Oh, but here it says increments of 1 and minimum 1. Okay. Anyway. Yeah, we have 100,000 on back order. Yes, Michael, I think you are quite correct. All right. I'm going to get back to that. So after the stream, I'm going to actually go hunting for stock of W5500s and order some. B. Edmondson asked about part substitutions, and the short answer is not without board changes. There are... Ooh, that's kind of a complicated... It sounds like a simple question, but there is a complicated answer. And I don't think I'm going to chase that squirrel right now. There are a number of different WISnet chips that have semi-pin compatible footprints, because what WISnet have done is, as they have developed new generations of their parts, they've brought them out in multiple footprints, and some of the footprints, it's a little bit like the Scilabs chips, like the CP21 series USB to serial converters. Like the CP2102N comes out in 3 different footprints, and one of those footprints is specifically backward compatible with the CP2104, etc. So there are possible substitutions within the WISnet family, but they will have a slightly different internal architecture. They need slight changes in drivers and things. So I will do everything I can to avoid that. I don't want to end up with a mishmash of different semi-compatible parts on the same footprint. So that was a good suggestion. It's definitely worth checking out, but the situation with WISnet part substitution is complicated. Let's just say it's complicated. So what was I talking about? I have totally lost my train of thought. Yeah, Aaron said, what's the cheapest donor board with a W5500 on it? Yes, basically the cheapest donor board is those ones that I just showed you, that I've got in my plastic tub of W5500 stuff. And these donor boards, oh, where is it? That one right there. Yeah. Yeah, it's 5500. So these are donor board candidates. I can just float some off. In fact, I think I've already done that on, maybe not on these ones. I might have thrown out the board that I took the part off. But yes, these are potential donor boards. If I can get more of those. It costs more than the bare chip, but not surprisingly not a whole lot more. Just a little bit more. Yes, Jax. I'm not going to chase that squirrel. And then, got to get it. Price per unit. Dodgy keeps asking about the price per unit. All right. That segues into the topic, which Aaron has just pointed out, is URC compatible. Yes. Okay. So what I was going to do here was zoom the camera back out and look at the URC project and what it is that we're trying to achieve here, and that ties into things like the pricing issue. So my prop for this part of the discussion is going to be back to the little keynote mock-ups of the different board arrangements. So starting with this, which is my first application for the universal rack controller, is to build light switches. So putting in this light switch controller breakout, the I2C to RJ45 breakout, but that's only one application. And if you look at the major components in this, there is the enclosure, so the metalwork. We've got the controller board in here. We've got the OLED with its breakout here. And then we've got the specific thing in here. And yeah, the specific thing in this case being the light switch breakout. So the light switch breakouts, I've ended up pricing kind of higher than I feel comfortable, but it's still not high enough to, it's not going to become my job making this stuff, put it that way. I'm not going to be taking any money out of this. So then if we remove that specific thing, so if we look at this, okay, so this version is the universal rack controller without the customization for the light switch. So it's just a generic shell of a project. What we need to look at is the costing on the various components that go into this. B. Edmondson said I should order the parts right now. Okay, but please no, nobody on the stream go and order all of those W5500s right now before I've had a chance to order them. I trust you. So, okay, so the cost of this board. This version of the controller, so jumping between that and that, the pass-through version. So the difference between these two is that one of them has, this one has the fully featured rack controller with the ESP32 and PoE and everything else on it. And this one is a simple pass-through board that goes to whatever you want to put in the back, like a Raspberry Pi or whatever. And so the cost of this board, just that board on its own, this number is not finalized, but to even be able to put the time into doing this, I need to be selling these for about $90, which is a lot. That is not covering, that's not actually not covering my time working on it. That is, that's covering like bill of materials and assembly costs, and it's not covering the time, it's not covering things like tech support and customer service and warranties and all of those sorts of things. Sion, $8, I'll give you $9 for all of your chips. Aaron says, I want a CM4 URC. Yeah, well, that can be a thing that follows. So we could do a version of this with a CM4 on it. So yeah, so I'm saying $90 for this board. Just the board. That's not the enclosure and the display and all of the other stuff. It's the controller board that goes in here with the ESP32 on it. I did just spit it out. Oh, maybe it's just the delay. $90. So the number, okay. I'm going to, where are we? I'm looking for windows here. Where can I find the other window? That window is what I want. And am I in the right account? Okay. I think I'm going to open the can of worms. And so I'm going to show you how I worked out costings on this. And Frank says, why bother if you're not making decent money out of it? Well, none of this has really been about making money out of it. It should be, but the reality is that it's not. Hang on, I'm going to move this across a little bit to about there, maybe. Where can you see? I'm just looking for where you can see all of the columns. I'll move this across. All right, now this is how I have calculated it. Now, it's as much as an ether mega. Well, yeah, it's got more on it than an ether mega. So, this is my BQT spreadsheet, batch quantity totals for the production of the Universal Rack Controller ESP32 version. So, what you can see down here, first column is references, so it's fairly self-explanatory. The value, the footprint, unit price, and pad count. Pad count is an interesting one that I will get to in a while, but that's basically just how many solder joints there are on it. So you can see we've got a bunch of electrolytic capacitors. No, not electrolytics. There are some electrodes down here. These are just like ceramic capacitors. And this is all in US dollars, by the way, because when you buy this stuff, pretty much all of the costs are in US dollars. Do these prices include shipping costs you paid? I try to include shipping costs. It's in the way I figure out the price of these things. So if I get down to here, for example, this is the Vroom 32 module. It costs me $3.30 in US dollars for a Vroom 32 is how much I've budgeted. And that budget would have included the cost of postage to get it to me. So if I ordered, so I typically order Vroom 32s in quantities of like 50 or so at a time. So if I ordered 50 of them and there was $20 of postage on it, then the $20 gets divided across the 50 and added on. So it should be including postage. Of course, there is no allowance on this for wastage. Things like you get parts and then they're faulty or whatever. This is assuming 100% perfect yield on everything. So, but that gets factored in later, kind of. So what we're looking at here is the raw cost of each of the individual components and the pad counts. Now on some of these I've got links to places, like to suppliers and things, just for my own purposes. And there are some, I'm not sure, yeah, there are some here that are like 0 because it's just a header that's got nothing on it, doesn't even have pins on it, and I've got a thing, do not place, no solder on pads. And then yeah, so all of this is pretty standard. You can export this sort of thing, some of these columns, out of Eagle or KiCad or whatever. Nothing too exciting in there. And then it's just got LEDs and what color they are. Now the bit that I've always been hesitant to show is the bit that is just off the screen right now that you're about to see. This is the thing that is going to this is revealing behind the curtain in a big way. All right, here we go. This little yellow box here is where all of the interesting stuff is. So what we've got is unit price on all of the items, and then the first row, so BOM price, bill of materials price in US dollars, is $23.86. That is just a direct sum of the column. That is the raw parts prices on all of these. And you can see here, this number, 389, that is the number of solder joints. So if we go back to the top of this, you can see pad count. Most of them are 2-pin parts, of course, but the Vroom 32 has got 39 solder joints on it. There are 48 on the W5500, etc. Why, hang on, why does that have that? That should be 12. That was a mess up. So there should be 12 solder joints on the micro SD, and then down the, has that changed it? Yeah, that's changed it. Interesting. So 401 solder joints on this board. Now, PCB price. All right, so bill of materials price. And the thing is that this is where a lot of people stop. They look at the bill of materials price, and that is just the list of, it is the sum of the prices of the parts on the board, and don't go any further. And often things like the PCB will be listed as an item in the bill of materials. All right, so what I've done here is separated out PCB price in US dollars. Because this is a 4-layer board with a non-standard solder mask color, and they places like JLC PCB charge an extra engineering fee for that, then the board comes to about US $4.70 for the bare PCB. Okay, so these other numbers, these will require a little explanation. BOM kitting fee. This is the raw bill of materials price plus 20%. So it's, well, it is 20% of the raw thing, and that is to allow for a few things. There is always wastage when you're loading pick and place machines. There's cost involved in just receiving the stuff and filing it somewhere. and disposing of packaging and the time taken to place the order for it. Like, the thing is that if you look at the price of a part, someone has had to sit down at a computer and do the inventory management and figure out, oh yeah, we're getting low on this sort of thing, we need to order another reel of that. They're going to spend 10 minutes sitting there at their browser placing the order. So you've got overheads in relation to ordering the parts, storing the parts, disposing of the packaging, wastage on the machine. There is like a huge list of extra things that soak up cost in relation to parts beyond just the raw bill of materials. So the bill of materials number that you calculate as the total of the parts, that is just the start of it. There is way more than that. So this BOM kitting fee is a 20% premium added on top of that to partly account for some of those extra costs. It's just like a little bit of extra padding. So then we've got an assembly price, which in here is $4.01. Now this one is an interesting one, and this is not necessarily the cost of what it takes to make the board and put it all together. Okay, what this is in fact, you can see this is kind of it's a simplified shorthand way of accounting for extra expenses based on the complexity of the board. So you can see that 4.01, so $4.01, actually corresponds to the pad count. What is going on there? So you can see that our pad count here is 401 pads. So we've got a total of 401 soldered joints. So in assembling a board, there are other expenses. There is, so this assembly price, the way it's calculated is, it is 1 cent per soldered joint. It's as simple as that. That formula is just solder joints times 0.01, and it gives you a number of $4.01. Now, what this accounts for and what this scales for is the size of the assembly job and things like solder paste that you have to use on the board, cleaning fluid that goes into the ultrasonic cleaner, time for running the boards through the dehumidifier after they've been washed, and like power to run the dehumidifier, and also basically other associated costs. So there are lots of costs associated with putting the board together that scale with the complexity of the board. And this is a dramatic simplification because things like soldering through hole joints take a lot more time and effort. They take manual labor typically, unless you've got a soldering machine, than surface mount. So if you've got surface mount parts, it goes through you stencil it, goes through pick and place, goes through reflow, goes through ultrasonic cleaning. And apart from someone picking the boards up and moving them around, it doesn't really make any difference in terms of how complex the board is. It's all the same amount of time involved and manual overhead involved. But things like manual solder joints, putting headers on and then soldering all the connections, that can take a long time. So things like the light switch breakouts, those I2C to RJ45 breakouts, they've got a huge number of hand soldered joints on them because they've got those big 8-way 8P 8C connectors on them. So the overhead can vary a lot depending on whether it's a fully surface mount board versus a board that has lots and lots of hand soldering. And so this number here is a dramatic simplification, but essentially what it's trying to do is cover a little bit of those extra costs that are associated, like like solder paste. And solder paste can be expensive. You know, a little jar like this that you just hold in your hand easily can be, depending on the ball size you get, like T2, T3, T4, T5, whatever, they have different prices, but it can be $80, $130, somewhere in that ballpark for a little jar of solder paste like this. and you'll go through the solder paste over the space of a few boards. So, as you go through panels. So the assembly price number here is to try to cover some of those costs. Solder paste, cleaning fluid, all of the other things. Even things like you wouldn't think about, like going through using up nitrile gloves. You've got to buy a box of nitrile gloves every now and then because you've got to wear gloves while you're handling all the stuff, and then you've got cleanup and you've got to throw the gloves out, and then you buy more of them. So this super, I'm spending a lot of time on this number, but because it kind of wraps up a whole lot of stuff into one thing, which is super oversimplified. But as I said, the way that I do this is it is the number of solder joints, or the pad count, times 1 cent. And that is what comes out to this value here, which is like, it's not the cost of assembly, it's more like assembly overheads. Okay, so then we have packaging, and in this I've just put in 50 cents. You got to allow for something like an anti-static bag, or however it's going to be packaged. And depending on the size of the thing, you might need large bags. I've got a like a heat sealer here, so what I do is put things into anti-static bags and then heat seal them. And then I have cards that are custom printed, like header cards. And I wonder if I've got some here. I've got some around. Oh, actually, I'll show you. So this is how they come. I will chuck a couple on the overhead camera. So it's like this. So these, I actually get these printed at Officeworks. And so it's, in fact so Officeworks have a postcard printing service, and I just get these printed as postcards, and then they stamp them down the middle with they've got some tool that just compresses the middle, which means that it always folds perfectly. And that's actually just a postcard size print, and I designed it in Illustrator with the 2 halves so that when it's folded, it folds over like that. So these cards cost, I can't remember the number, but they're not super cheap. They're like 10 cents, 15 cents, maybe 20 cents each. So you have a card plus an anti-static bag, and then you've got to allow yourself 50 cents for that. So in that case, this is just an extra 50 cents added in there. So by the time you sum these things in the orange section just here, we come to $38.78. And so this is the difference. A lot of people will look at the bill of materials price as $23.86 and they'll stop there. But that is not even starting on what the costs are, like what the out-of-pocket costs are before you even begin assembly. So this number here, the total price, $38.78, that is more like the actual out-of-pocket cost of the parts and things that go on this board. Okay. Yeah, Arseon said, my stencil cleaner plus USC chemicals combined are about $400 per 5 litre. Yeah, it goes up. There are lots and lots of expenses. So, okay, so $38.78 US essentially is what I'm out of pocket for the parts for this, not even counting time to put it together. So not counting time spent on assembly, which is a whole extra thing. So this number here, 52.41. Oh, and I've got the exchange rate down here. So currently the Australian dollar is trading at about 74 US cents. And so this calculation of $52.41 in Australian dollars is what I'm out of pocket for every universal rack controller board that I will assemble. And that is assuming that zero like failures, and also all those sorts of other overheads as well. So it's not allowing for things like rework time and and actual assembly time. Okay, so Aaron has just pointed out R&D, testing, admin, sales, advertising, and support. Way more costs involved. Yes, yeah, and this is why this is why Freetronics and Superhouse lose me money. So, all right, $52.41. I'm out of pocket before I put in assembly time and all of those other things on these boards. So then the okay, let's do a little calculation here. Equals that times, I'm going to put in a number of 2.6. So the generally accepted, very rough rule of thumb is that your raw costs times 2.6 should be your minimum retail price. And this is, so at that rate, it comes to $136. So these boards should be $136 Australian retail, is what that's telling me. So based on this. So when I give the number of 90, it is, I always feel like I'm asking too much. And so I pull the number back in my head because I think, no, people won't want to pay. A number like $90 for this board seems ridiculously over the top to me. That seems way too expensive. And so basically take the manufacturing cost and add 70%, take that number and add 70% more. Yeah, so let's do it that way and see how close it turns out. So we'll say this one is equal to the, oh, I hate the way the stupid thing jumps up and gets in the way. All right, I want that times 1.7. 1.7, so that's adding 70% on it. So it becomes 89. And then that is going to be equal to that times 1.7. So add 70% on top of that as well. So it's compounding. Yeah, so according to Lady Ada's formula, these boards should be $150 each. And yeah. Yes. So Sion says, I have to add rework for failure's time. Yeah. So anyway, if the, let's do these two, make those currencies, and that's by 2.6, and we'll say this is Lady Ada. So by the 2.6 multiplier, it should be $136. By Lady Ada's formula, it should be $151 for this board. And so this whole issue extends to things like the products I sell through Freetronics. And I cop it fairly frequently, people telling me things like the Ether Mega are ridiculously overpriced, because that one goes for $119. And it's not so much recently actually, but I used to get abusive emails. People would send me emails saying, how dare you charge that much, you're a rip-off, and yeah, just nasty stuff. And if you look at say an Ether Mega, I'm not going to go through it now, but if you do this same bill of materials calculation on an Ether Mega, it costs more than this board to make. And I'm selling them at 119. So if I have to send out a replacement, like a warranty replacement board, what this allows nothing for is me answering tech support emails or customer support or anything like that. Like basically all of that, I just have to do that in my own time. I don't take any money out of the business. So like if I have to send a replacement board, then that's $119 worth of board that has been shipped out. So 130 AUD is 95 Ameribucks. Yeah, okay. Yeah, Frank says let them make their own boards. Yeah, I've actually replied I used to get really narky. Now I just ignore those sorts of emails. But for a little while, when people would send me abusive emails saying, your boards are too expensive, I would just reply and say, here are the design files, make it yourself, and link to the GitHub repo. So, yeah, anyway, the point is, I don't make any money out of either Freetronics or Superhouse with the way the pricing is done. I would have to sell my stuff for way more than I currently do to cover the time that I spend first in designing the things and then in after sales support and all of that sort of thing. So yeah, Freetronics and Superhouse don't make me money. What actually keeps me alive is contracting work. So people pay me by the hour to work on their commercial projects. And all of this sort of thing, it kind of covers itself, but a lot of it is just coming out of my own pocket. So anyway, I've done it now. I've revealed the secret sauce. This is the calculation of how this is worked out, and yeah. Anyway, I need margin to feed Steve. All right. So Sion says, according to later 80, your tiny picos should be $29 each. What do tiny picos cost? tinypico.com. For anybody that doesn't know, Sion does these amazing little boards called tiny picos, and a few other boards as well, but this is what we're talking about right now. So if you're after a really cool ESP32 based dev board with onboard battery management and all that sort of really cool stuff, these are worth checking out. And buy a tiny pico. So can we buy them directly from you, Sion? Tiny pico V2 USD from $22. So you're underpricing it. That's what you're saying, isn't it? You should be charging more. Yeah, you should be charging $29. And Sion, I bet you get people complaining about your pricing being too high with the tiny pico at 22 US dollars. Let's see, select a pack single. I bet you get people telling you that you are overcharging for this. Even though this is less than what you should be charging in order to just be making this worth your while to be doing it. 22 now was 20. That is so cheap for what it is. The problem is that people do a comparison to something like, like a Lowland 32 Lite, and firstly, it's not a fair comparison. It's not but you look at a Lowland 32 Lite and it might be US $4 or something on AliExpress. And so people look at that and they say, oh, the tiny pico, it's $22, it's so expensive. But what you're getting, there are so many reasons for that. Some of the reasons we've already gone into. Some of the reasons is that it's just not a direct A-B comparison. This is a totally different board to something like a Lowland 32. It does way more stuff. It's designed in a totally different way, so you can't directly compare it. I think you get far more with this. This has big advantages over the other, over some of those cheap boards. But the problem is that people just do that comparison. They'll look at product A and product B, even though they're not the same thing, and say product A costs this, therefore product B should cost the same. No, they shouldn't cost the same. They need to cost what they need to cost. So, yes. Sion says every day. Yeah, I feel your pain, Sion. I know exactly what you mean. So yeah, how long has Freetronics been around? 12 years. So 12 years I've had people emailing me constantly saying your prices are a rip-off. Yeah, and I see it quite often in public places as well. Like I used to see it quite a lot on the Arduino forums, people just talking about my products and saying how expensive they were. And yeah, I see it, I come across it in Facebook groups and things as well. Like nothing, no Facebook group, nothing that's related to me. It'll be like just some electronics group or like an IoT group, and someone will talk about those rip-off Freetronics boards. Anyway, yeah, and what they don't understand is at those prices, it's still not enough to actually pay me to be doing this. Yeah. Yes. I didn't expect to end this for this to end up as a pricing rate. What? I think because oh, Chip says lunch soon, yes. So, this is the thing is that, okay, look at these numbers. If I do my by 2.6 multiplier, it comes to 136 retail. If I use Lady Ada's double 70%, it comes to 150 bucks retail, give or take. Now, let's look back at this. That is just this board. It's not the enclosure, it's not the LCD, it's not all of the other expenses, it's not the back connectors, it's not everything else associated with making this device. So if this board went for, say, 150 bucks, and then the enclosure, say the raw cost of the enclosure, I'm going to make up a number here and say the raw cost is 40 bucks. So say the raw enclosure we need to retail for, let's say 100, plus some other bits and pieces are up for 250, plus other odds and ends. This could end up being a $300 product, and it's a box with a board in it. And it would sound like a, to me that would sound like a rip-off. I would think, why would I spend $300 for an enclosure with an ESP32 in it? So this is the problem, is that in my head, I keep doing this thing of, how do I justify this to myself? And I don't necessarily need to justify it to myself. I just need for other people to care enough that they want it. So that's the important thing. All right, so, oh, Johnny said, so we're agreeing on a price of 140 AUD. That seems too much. Sion says 129 sounds like a good price. That actually does sound like a, yeah, so let's put 129 in here. There's the whole pricing theory as well. Like, you know, these price points of $89, or if you say something is $100, it seems so much more expensive than if you say it's $99. And psychologically, there are a number of those sort of price points. 129 is a good number because it has a 2 in it, and the 2 is a low digit, the 1 is a low digit, it ends in a 9. So 129 sounds a lot cheaper than, say, $130 or 136. Like if you think about, if you saw a $129 price tag, the psychological impact of that versus seeing a $136 price tag is significant, even though it's only $7 difference. So yeah, 129 is a good sort of magical price point, I think. I like that. Yeah. Aaron says, but it's a magic box. Oh yes, and also Aaron mentioned earlier, we have the ads now to justify it. This is so cool. Let's see. Discord, is this going to open on a private chat in the public window? Let's see. Hopefully not. Hopefully it opens in a public, whatever I last had open in Discord. Yeah, Dodgy says, say 99 and I still hear 100. Yes, I know. But it is, there is still, that you mentally round it up, but still, yep. Now, I'm just going to show you some really cool things that Aaron did. These are so funny. Funny in a good way, I should say. Where is it? Where is it? It was in the universal rack controller. Oh, there's some chat I've missed. Okay, so check this out. This ad, have you switched? Take control with the ultimate flexibility. So Aaron has mocked up some ads for the light switch controller. This is the breakout. And this one, can you control the darkness? Take control with the ultimate flexibility. So yeah, we have ads. Which means that we can charge higher prices now. 127, so it doesn't look like you were trying to trap the 130. Yeah, I don't know, 127 to me feels like a strange number. I know this is really weird, but a price that ends in 7 feels strange to me. Yeah. So, yeah, I should make this my desktop. This is so cool. Yes. Where was I going? Oh yes, where I was going is that it's lunchtime. And I've spent the entire time talking about the universal rack controller. And including pricing. We didn't talk about the multimeter thing at all. All I'm going to do, yes, Aaron is a legend. All I'm going to do about the multimeter interface is mention that that there has been some decoding stuff done. So the firmware is making some progress. We need to have a conversation, and this I think probably should just be done in Discord, about the format for the JSON messaging so that we can actually nail that down and have a definition of how the data is going to come out of the multimeter and go to the client, be published to MQTT so that the clients can consume it, and then Aaron's very cool client like multimeter interfaces can, in fact, where is it? If I go to here, yes, here it is. This is a slightly out-of-date version of Aaron's multimeter interface. And it's sitting there ready to receive data. If we were sending data to the correct MQTT channel, we would be getting values popping up on that display right now. But what we need to do is finalize the format for the data. And yeah, let's do that on Discord. Then, yes, where was I? I don't know. Where I was about to place an order for a whole lot of W5500s. Okay. I think I need to wrap it up. I think it is lunchtime. Since Chip has been the honorary Peter today and has prompted for lunch. Now, what was I looking for? I was going to go back to here. I just wanted to wrap up on the universal rack controller. Okay, so personally, I am really excited about this. I think that this project is one that has so much scope way beyond what I originally conceived for this, and I really hope that what we can do with the help of all the people that have been contributing on Discord already, there are so many people involved in this now, that we can build a project skeleton or template with the mechanicals and the basic power and interface elements that you can then use to build whatever you like. And I think this will be a really, really cool thing to do. So Aaron asked, what's your position on progressing the case design? My position is that we need to, but I have not thought a lot about it myself, other than seeing messages go by and CAD concepts go by in Discord. So it's definitely time to bring all of those concepts back out again and talk about how we're going to do this, like exactly how this case needs to be made. And then I need to order some metalwork, and hopefully that will not take too long, maybe a week or two to get the metalwork done, because I can get that fabricated at Quality Metal Solutions just down in Bayswater. They can do the laser cutting and the CNC folding and everything. And then we're probably only a couple of weeks away from having this entirely functional with metalwork and boards and everything, which is really, really exciting. That will be a great thing to see. All right, Mako says, Mako's mind goes south when hungry. My mind, yes, I am hungry and my mind is south. Eat a Snickers. Yeah, so Gil says, how about a front that allows you to use some kind of template to fill the holes like they do in PC cases for the motherboard I/O connectors? Yes, that is exactly, so if we go to this slide, that's exactly what this one is for. So my general concept is, initially at least, to produce 4 versions of the front plate. There will be one that is totally blank, and that will be for selling just the enclosure, because there are situations where you'd want the enclosure without any electronics because you're going to build everything yourself. So that's the simplest case, enclosure with a totally blank front panel. Then there will be the enclosure with the infrastructure, so it'll have the URC board in it, so it's got Ethernet and USB-C and it's got the display, and then you can build the rest and you can cut whatever holes you like. Then there is a version which just has a big cutout on the front, and then what you could do is 3D print a bezel or laser cut a bezel or whatever you want to do. You can fit something into that hole, and then you can mount your boards inside it and then have whatever custom connectors you want on here. And the 4th version is the one that's optimized for the light switch controller, and it's going to have 3 rectangular cutouts to allow these connectors to come through the front. So yes, we got you covered in terms of making a custom bezel or something to go in the middle. That will be one of the options, I think. So I think what I'm going to do, when it comes to fabrication, I'm not necessarily going to get all 4 of these fabricated straight up first time, because we're going to need to be able to, we want to do test fits and make sure that things work properly. So I think probably the very first one I do is going to be the one for the light switch controller, and make sure everything fits. And then if that all fits properly and there aren't any adjustments needed, or once the adjustments are done, it's a simple matter to do the other versions. It's just deleting the holes basically, and then we know we are good. So start with the most complicated version and get all of the alignments and fits perfect. And then the other ones are very simple derivatives of that, just with holes deleted, and in this case, 1 hole added. So yeah, the bottom one will be the first one fabricated, but ultimately I think all 4 of these will be fabricated. And if it turns out that there are other derivative projects of this that are popular, and there is a call for doing one with a faceplate that is optimized for a different purpose, like, you know, the smoke detector controller or a security system controller, or like security sensor interface, or whatever, an audio distribution matrix, whatever it ends up being, we can then extend and we can make custom faceplates for those as well. Okay. B. Edmondson 85 says, don't forget about the WizNet chips. Yes, thanks for the reminder. I have it open right here in my browser as the front tab, so I'm going to leave it there until I have ordered them. I'm not going to forget about it. There are a couple of other parts that I need to order for this as well, but the others aren't nothing I'm worried about. I just need some inductors and a couple of other, you know, really simple jelly bean parts that are easy to get. It's the W5500s are the thing that are giving me worry. Oh, Cable Tie says there are no thumbs down today. There's still time. There will be some thumbs down, I'm sure. I always get thumbs down on my videos. All right, So, Steve the squirrel. Yes, where's Steve? Steve is on the PCB. Okay, after lunch, as Cable Tie says, because I need to eat, you need to eat, and then I need to order WizNet chips. So thank you very much everyone for coming along and being a part of this. And if now that we're moving on to the case, like the enclosure design discussion seriously, now would be a really good time to jump into Discord. If you haven't been on the Superhouse Discord yet, please come along and join us and talk about all the ideas about how the case should be made for this so that we can build something that is useful for as many people as possible. So, still trying to find things on this new setup. Okay, thanks everyone. I hope you have a great Sunday and I will talk to you all soon. Bye.